Hello, welcome to today's science experiment. Now, I'm really excited about today's science experiment because I've actually never seen things like this happen before. I didn't know this was possible. So I was really excited when I was doing the different parts of the experiment. So I hope you're really excited too. Now, we're still going to be using things you can find in your kitchen or your pantry. So it's really easy for you to do the same experiment at home. So all you need for the first part of the experiment is eggs, a container that's glass because it's easy to see through and see what's happening, and white vinegar. So in this experiment, we're going to be using a lot of quite big science words. Now that might seem a bit overwhelming, but by the end of the experiment, I hope that you'll be able to understand and maybe even use those words in the future, maybe when you're explaining your results to your family or somebody at school. So I'm going to put my glasses on because such big words need glasses. Okay, so I'm going to tell you now what the words are, and I'll put them on the screen, but I don't want you to be worried because we will explain what those words are as we go along. So there's 8. We're going to use the words calcium carbonate, we're going to use the word dissolving, membrane, carbon dioxide, acid, translucent, molecules, and the big one at the end, semi-permeable. They are big words and they seem a bit overwhelming, but I will help you through. Okay, so I hope you are really going to enjoy today's experiment, and if you can do it at home, that is even better. I'm going to show you step by step what we're doing, and I'm going to show you the progress of the experiment as we go along. If you can follow along while I'm doing it and pause during it, that would be even better. I'll see you on the other side of the experiment.
These are the materials we're going to be using for this experiment. To start with, eggs, a glass, and plain white vinegar. We're actually going to be using raw eggs. I'm going to place one of the raw eggs into the glass, trying not to crack it because it's really important that we don't crack it. And here I'm actually going to put a couple more in just for the next part of our experiment. I'll put 3 in. The next part, I'm going to pour some vinegar over the egg, and we want the whole egg to be covered. And because I'm doing the extras for the next part of the experiment, I'm going to use quite a bit of vinegar here because we want the whole eggs to be covered. They're starting to float to the top, so I might have to turn them around occasionally. Oh, this one needs a bit more because it's not quite covered. There you go. That egg's got a smile on it. Did you see that? It's very happy to be in this experiment. Now our happy egg here is already showing us some results. I only put it in a minute ago. So vinegar is an acid, and the acid in the vinegar reacts with something that's in the eggshell called calcium carbonate, and it slowly starts to dissolve the calcium carbonate in the eggshell, and it's making a chemical reaction. It's producing carbon dioxide bubbles. That's the little bubbles you can see on the surface of our egg. Now we have to leave it for about 24 hours total, but I'm going to show you what happens in a few hours because the outer layer of the egg is going to start to dissolve. That means when it kind of becomes part of the water. When you dissolve salt or sugar in water, it kind of becomes part of the water. Now I moved my 3 eggs into a different container so they could be fully submerged. That means right underneath the water, completely covered. And you might be able to see that Already the shell is starting to dissolve because you can see some lighter pieces there. You've got to be really careful not to get a crack in the egg when you're moving them around. Okay, they've been in there maybe 4 hours, and oh my goodness, can you see that all of the shell is starting to dissolve off? So kind of disintegrating, which means breaking down into the vinegar. And you can see, if we turn this around, this egg, you've got to be really gentle with it because it's so delicate. See, all the brown shell is coming off. And it's kind of floating around. We've got to wait 24 hours. There is all the brown eggshells floating around. And do you know, if you look really closely here, you can see a little bit of red dye. That was from the smile of the egg. This is after 24 hours, and all the brown shells have been worn off. And you can see here, if you just rub that, I'm going to pick up this egg. Oh my goodness. When you pick it up, you will notice it's very slippery. And I wonder what some other words we can use to describe it. Spongy. And if we actually rub our finger, we can see that some more of the brown shells coming off. So I actually think these need a little bit longer in the vinegar. I actually cracked the egg accidentally on this one. And you can see the yolk and the egg white around it are still sticking together. And then you can actually see, so the egg shell has all been dissolved away. You can see part of it here, but this is the membrane.
Okay, so this is part 2, and we're going to talk about the membrane that we saw, the skin of the egg. Okay, I'm going to tell you something that's very newsworthy. The membrane is what we call, and we're going to use one of those big sciencey words now, semi-permeable. Semi-permeable, okay? So I'm going to explain what that is. Semi-permeable is a big science word that we are going to use to describe the membrane or the skin. So I'm going to give you a little example. So if I open my fingers here, I can get my pen through. But I can't get my mouse through because it's too big. So the membrane being semi-permeable means that some things can get through that are the right size. So water is the right size to get through the membrane of the egg.
Okay, this is 48 hours and pretty much most of the shell's gone. We can just rub it off with our finger. If you're finding that it's not just coming off with your finger, you can put it under the tap. But do you know what is happening? Is that the egg has become a bit see-through or translucent. That was that word I told you about. We can kind of see the yolk inside there now that all the shell's gone. I'm going to wash these 3 eggs and I'm going to show you something that you can do at home. Now that I've washed them, you can see even more how translucent or see-through they are because you can see the egg yolk in each egg. Now, do you remember I talked about the molecule size and how the eggshell wasn't letting any of the water or vinegar into the egg, but now that it's just a membrane around the egg, the water can get in. Now I'm going to show you something. Look how big the egg size started. They actually look a little bit bigger. Let's compare. Oh, my fingers have got eggshell on them. Let's compare this one. Can you see how it's a bit bigger? Let's turn the happy face around. Because some of the vinegar has gotten into the egg. Now we're going to give you some time to do a couple of experiments yourself. Because do you know these eggs can bounce? I don't want to bounce mine very high because I want to use them for the second part of the experiment. But you can put a ruler here and see how high your egg can bounce without breaking. So they can bounce now. Isn't that amazing? Now, while you're playing with bouncing your eggs and having a feel of them, how squishy they are, we're going to do the next part of the experiment, and I'm going to put one egg carefully in. Oh, they're so slippery still. Don't break them in each glass. Oh, I don't want to break it. Now, we're going to call this one in the middle the control. That means nothing is going to change with that egg. That's the one that we're going to compare it to. Now, do you remember I talked to you about how water will move into space that's available to it? So this one, we're actually going to put it in water to see if the water from the glass will go inside that egg and make it even bigger. This one we're going to do nothing, it's our control. And this one we're going to put it in corn syrup. If you can't find corn syrup, I want you to try and use glucose syrup or something similar, just to see if you can do it at home. If you are only watching here, that's perfectly fine too. Now I'm going to put the water and the corn syrup into the two outside glasses. Now I couldn't find corn syrup or glucose syrup, so I'm going to use agave syrup or agave syrup, and we're going to see how that works, whether it works or not as well, whether it will do the same job. Okay, so I'm going to cover this egg. Oh no, I have to take the case off. Hang on. I'm going to cover the egg with the syrup. Remember, it has to be fully submerged. Oh, look at that, it's floating. And then I will do nothing to the control. And water to the first one. And then I'm going to leave them again. Lots of patience needed in this experiment, isn't there? Remember, we're looking at molecule size and what things will go in and out. So we're looking at how the molecules will move into the space or out of a crowded space. Now I'm going to add a couple of drops of food dye, different colours, to each experiment so that we can remember what we did to each one. Otherwise we might get them mixed up at the end. So this is the water. This is the control where nothing is happening apart from food dye, and I'll get rid of that extra food dye, and this is the syrup. Okay, now here we have the results of the second part of our experiment. The red was in water, the blue was the control, and the green was in the syrup. Now you can see that because there was water in the egg and not as much water particles in the syrup, the water has gone out of this egg, and inside the yolk is really, really hard. And then we've got the blue control compared to how the egg started, and this is the amazing one too, the red one that was in water. All the water molecules have gone from the cup, or a lot of them, into the egg because there wasn't as many water molecules in there, so there was more space. So you can see it's much larger. It's larger than the blue, and it's way larger than this squishy green one that was in the syrup. I hope you had a great time with this experiment, and I hope that if you did it at home as well, you had a lot of fun. Now don't forget, these are bouncing eggs, so you can have some fun now, seeing how high they can bounce. Be careful not to break them.
I hope you had a great time watching that experiment and doing it at home if you were able to. And I hope that you can explain to somebody all of the chemical reactions and what happens. I'm very proud of you being such an amazing scientist. I'll see you next time.